between the vertical asymptote and that intercept. So we will make, for example, like -2, then you get -1.8. So we get the points somewhere like this. Okay, and also we need to make the one that near to the vertical asymptote. So we need to make -3.9. When you plug that in, you get a negative big number. So I'm going to use infinity for that. Okay, so the point that we got is somewhere down here. So basically you can connect like this. And then from the two x-intercept, we need to make the points in the between. So we will make 0.5. Then you will get the answer is 1/15, which is about 0.07. Okay, so then you can connect like this. And then you will make 2.9 and 3.1. There will be very big number or very small number. You need to input by yourself and find out those numbers. That means we can continue to approach from 2.9 you get a negative number, so it's gonna go down here like this. And then 3.1 and also the graph approach like this. We make the point on the right hand side of the graph, so right here. So we will make like 5, 6, 7, 8 and so on, right? So if we make like 7, we will get the point is 2.86, and if we make 4, we will get 4.5. So the point 4.5 is 4.5 is right here. So we will make it approach because we get the very big number when we get 3.1, and then you can make it approach to the horizontal line. However, we need to be careful with this. In this case, the correct graph for this piece right here, the yellow piece that I make, it will be touching the horizontal asymptote, because you know that the graph, they may or may not touch the horizontal asymptote. Yeah, and you may ask me why I did not talking about that in example 1, example 2, example 3, but why we talking about this in this problem. Okay, so let's solve it first, and then I will go back and tell you why. But in order to find the point where the graph meeting the horizontal asymptote, we will do like this. Let's write out the equation of the horizontal asymptote, and let's write out the equation of the graph. So we got 3x squared minus 3x, the rational function, and we got x squared plus x minus 12. In order to find the point where they meet, we need to set both of them equal of each other, because y equal to both of them, so y equal of each other. 3x squared minus 3x divided by x squared plus x minus 12 equal to 3. We will multiply both sides by the denominator x squared plus x minus 12, and we can do that because we already find the domain and we already exclude the two numbers before. So we got 3x squared minus 3x equal 3x squared plus 3x minus 36. We can minus 3x squared both sides. Then we got negative 3x equal 3x minus 36. We will subtract 3x both sides. So we got negative 6x equal negative 36 and divide both sides, so we get x equal to 6. So when x equal to 6, the y part will be 3. The point where they meet will be x equal to 6 and y is 3. I got 3 right away from this equation. If you want to check, you can input 6 into the x in the function r of x. So you will get the answer is 3. So that is the point where they meet each other. So what I'm going to do is I should go back and I need to erase this curve, the red curve, okay? Then I will draw this again. So we're going to approach to the curve like this, but then at 6, 3, this point right here, the graph will come to the horizontal asymptote, and then it touch like this. And then I already calculate that 7,2.86. So 7 right here and 2.86 is right here. So it will come down like this, and then it will get approach to the curve in the bottom way, not on the top way. Okay, so it's gonna be like this. Okay, and then let's go back to the other problem. How come we did not find the points where they meet from the other problem? So let's review this. You look at this problem first of all. You see that if we ignore this step from the beginning, from what we did from this step, we make the points. From here so far, we do not have any points that touching the graph. So that's why it makes us think about somewhere the graph need to meet the horizontal asymptote somewhere. So that's why it makes us to solve. Okay, so go back to the other problems. So let's look at this one, example number 3. You can see that we do not have the horizontal asymptote. Okay, so that's why we do not think about that. We remember definition of the horizontal asymptote, the graph may touch. Okay, we did not do that because this problem does not have the horizontal asymptote. And then number 2 is similarly concept, no horizontal asymptote. So that's why we did not think about it. We did not do it, and we don't need to do that. And example number 1, we have the horizontal asymptote, and that line is y equal to 0, the pink line right here. Okay, and you see that look at this point, the yellow point, 1 right here. So that point is the x-intercept, and the graph is on the line y equal to 0, and is also the x-intercept. So actually our graph is already touched the horizontal asymptote already. Okay, so if you want to be careful, you can solve, but actually you don't have to. But you can solve for this equation. You write down the two equations, y equal to 0, which is the horizontal asymptote, and the function y, which is the rational function x minus 1 divided by x squared minus 4. Then you set both of them equal of each other and solve for the x. But then in order for this to be equal to 0, and you actually already did that. Okay, so let me tell you where. So it's right here. You already solved this. So that's why you already found during the process in step 5. But the other problem, we did not have that. So that's why we need to solve for the point where they meet the horizontal asymptote and the graph.